Happy day children. In the previous video we discussed about electric current from the topic measurement. Today we are going to study about measuring electric current using an ammeter. You all know the 7 fundamental quantities: length, mass, time, temperature, electric current, amount of substance and luminous intensity. Length, the SI unit is meter. Mass, the SI unit is kilogram. Time, the SI unit is second. And temperature, the SI unit is Kelvin. Today, we are going to discuss in detail about electric current and the circuit diagram and how to measure electric current. Electric current is the rate of flow of charges in a conductor. Electric current is given by the formula I is equal to Q by T. Here I denotes the intensity of current flowing through a circuit. Q denotes the amount of charge flowing through the cross section of a conductor. Small t denotes the time for which the charges flow through the conductor. Its SI unit is ampere. And you also know that electrons always flow from a higher potential to a lower potential. Let us understand the term potential with the help of this activity. Here we have two beakers. Beaker 1 in the left hand side and beaker 2 in the right hand side. Both the beakers are connected with a pipe and both are filled with water. The water level in both the beakers are same. Will the water flow? Your answer will be absolutely no. So here, why the water is not flowing? Yes, you are right. The level of water in both the beakers is the same and both the beakers are also maintained the same level. So what shall I do to make the water flow? See this case. Here, what I have done, I have brought beaker 2 to a greater height than beaker 1. So I have created a height difference here. So for the water to flow, we have to create a height difference. The beaker which is at a greater height, the water in that beaker will start flowing from that beaker to the other beaker due to the difference in the height. And you all know that all metals, they have free electrons in them. The same way, copper wire, even though it has free electrons, will there be a flow of electrons in it? Here is a copper wire shown in the form of a rectangular shape. So how can we make them flow? We have to create a potential difference. How we created a level difference or height difference for the water to flow. Here, in case of this copper wire, we have to create a potential difference. So what is potential difference? What does the word potential mean? Before we understand the term potential, let us recall the two types of mechanical energy. The two types of mechanical energy are potential energy and kinetic energy. The energy possessed by any object due to its position or shape is called as potential energy. A stretched rubber band possesses potential energy. A book kept on a table possesses potential energy. A ball raised to a certain height possesses potential energy. Then comes the kinetic energy. Kinetic energy is the energy possessed by any object due to its motion. Moving ball possesses kinetic energy. Moving bus possesses kinetic energy. A boy running possesses kinetic energy. So all objects in motion possess kinetic energy. Here you see a ball which is raised by the help of a hand is at a certain height. So due to its position, this ball also possesses potential energy. And when you drop this ball, the ball keeps on moving down. And the height of the ball keeps on getting reduced. So there will be a decrease in the potential energy. and finally when it touches the ground, the potential energy will be totally zero, and after falling on the ground it will keep on moving. So due to this it possesses kinetic energy. So the ball at a certain height possessed potential energy, and when it is dropped down to the ground it possesses kinetic energy. As we keep on reducing the height, the potential energy of the ball reduces or decreases. The same way as a ball moves from a position of higher potential energy to a position of lower potential energy, the electrons also tend to move from a higher potential to a lower potential. See this diagram in which the electrons tend to move from a higher potential energy to a lower potential energy. So, what creates this difference in potential or potential difference? This difference in potential or potential difference is created by a cell or a battery. Potential difference, which is known as voltage colloquially, is the work done to move a unit charge from one point to another point in a conductor. Potential difference is denoted by the letter V. Since it is the work done in moving a unit positive charge from one point to the other point in a conductor, it is given by the formula V is equal to W by Q. W here denotes the amount of work done and Q denotes the charge possessed by the conductor, charge flowing through the conductor. The SI unit of potential difference is volt. In order to honor the scientist Alessandro Volta, who invented the first cell, here the difference between cell and a battery is, cell is a single component. A combination of two or more than two cells is called as a battery. Here is Alessandro Volta, who invented the first cell, and you should know that every time it is very difficult to draw a cell. So, a cell is denoted by a long terminal and a short terminal. The long terminal represents the positive terminal and the short terminal represents the negative terminal. Potential difference is measured using an instrument called voltmeter. The red side of this voltmeter denotes the positive terminal and the black side denotes the negative terminal for connecting it to the circuit. Potential difference is measured with the unit volt, so the symbol V is given here. And a voltmeter is always connected in parallel to a circuit. You know the two types of connection, one is parallel connection and the other one is series connection. So voltmeter, how is it connected to the circuit? It is connected in parallel to the circuit. Look at this picture. Here we have connected a cell to a bulb using connecting wires. The positive terminal of the cell is connected to one terminal of the bulb and the negative terminal of the cell is connected to the other terminal of the bulb. So as soon as this connection gets complete, there is a complete flow of charges through this circuit and the bulb glows. So a closed conducting loop or path which has a network of electrical components through which electric current flows is called as an electric circuit. We have seen in the previous picture only a cell and a bulb which are connected using connecting wires. So there were two components there, and every time it is very difficult for us to draw those components as such. So for making the job easier, what we do is we always represent this electric circuit using a diagram which is called as a circuit diagram. So we can define circuit diagram as a schematic representation of an electric circuit using symbols of various components, which is called as circuit diagram. Let us discuss or go through some of the symbols of the simple components which will be used by us in drawing the circuit diagram. Here is a cell. Cell is denoted by a long line and a short line. The long line denotes a positive terminal and the short line denotes a negative terminal. Next is the bulb. Every time we can't keep drawing this bulb, so we denote it by an inverted W symbol and a circle above it. Next comes the switch. The switch only makes or breaks the circuit. So switch has two symbols. One in off condition, the other one in on condition. In off condition it makes a circuit incomplete. And in on condition it makes a circuit complete. In off condition there will be a gap between the connecting wire and the switch so that it makes a circuit incomplete. And in on condition there will be a continuous line. Last comes the connecting wire, without which no component can be connected. The connecting wire is represented using a straight line. Here you see we can compare an electric circuit and a circuit diagram. See here we have only two components. One is the cell, the other one is the bulb. So we have a simple circuit diagram. Every time it is very difficult for us to draw a cell like this and a bulb like this. So we can just go for circuit diagrams. So what is circuit? Electric circuit is nothing but a closed conducting loop or path which has a network of electrical components through which the electric current flows. Here how many components we have? We have only two components. One the cell, the other one the bulb. But the same electric circuit, when it is represented schematically using symbols of various components, we call it as a circuit diagram. Here we have represented the cell using positive and negative terminals and the bulb using its symbol, and it is connected using connecting wires, and the direction of flow of conventional current also is shown here. As we discussed previously, the direction of conventional current is from positive to negative and the direction of electronic current is from negative to positive. We always follow the direction of conventional current. From time immemorial, this direction only is used. As olden days, people used to think that positive only is at a higher level. So anything which flows from a higher level to a lower level. The same way people used to think, scientists used to think that the current is flowing always from positive to negative terminal. So it is being followed till now. It has not yet been changed. Here you see the same circuit, there is a small change. What we have done is we have interchanged the connections. If I connect the positive terminal to the other end of the bulb and negative terminal to the other end of the bulb, even though the bulb glows, still the bulb glows. How? Because the circuit is complete. If the circuit is complete, even the connections are interchanged, there won't be any hindrance in the flow of charges. The charges will flow, the current starts flowing and the bulb glows. But there will be a small change in the circuit diagram. Here, in the first case, the negative terminal was placed in the left side and the positive terminal was placed in the right side. But in the second diagram, when it is interchanged, the negative terminal is placed in the right hand side and positive terminal is placed in the left hand side. So, if you interchange the connections, only the direction of flow of conventional current alone changes, but the current still flows. Until the circuit is complete, the current keeps flowing and the bulb glows. Here, till now we studied only two components in the electric circuit. We have introduced a third component here. Can you name the third component? Yes, it is the switch. What is the function of the switch? As I previously said, the switch can either make or break a circuit. So, here you see, if the switch is in on condition, what happens? And the switch is in off condition, what happens? When the switch is in off condition, the circuit is incomplete, the bulb is not glowing. You can compare the electric circuit with the circuit diagram. See, you can see that in switch off condition, the circuit is incomplete and there is no flow of charges. But in the second case, you see, when the switch is on, the circuit is complete. And when the circuit is complete, the charges flow and the bulb glows. In this case, when the bulb keeps on glowing, how the bulb glows? There is a filament in the bulb. The filament gets heated up, and due to the heat produced, light energy is produced and the bulb glows. So, inside the bulb also the circuit is completed using the filament. But when excess amount of heat is produced in the bulb, what will happen to the filament? The filament will break, and as the filament breaks, the circuit becomes incomplete and the bulb will not glow. And this happens due to the excess heat produced in the bulb. Due to the excess heat produced in the bulb, the filament breaks and the circuit also breaks. There is no flow of electric current. When the cell of 1.5 volt is connected to a bulb using connecting wires, what makes the charges to flow? What makes the electrons to flow? The cell, as I said, is used for creating the potential difference. Negative terminal of the battery or cell, more of electrons will be there. Positive terminal of the cell or battery, less number of electrons will be there. So the electron density is higher near the negative terminal of the cell. And since electron density is higher, that is, the density of electrons per unit volume is very high, they will always try to repel the electrons present in the conductor near the negative terminal. And as they keep on repelling, the electron starts drifting. So this drift in the electrons will make the electrons to flow in one direction. And as the electrons flow in one direction, the flow of electrical energy also takes place through the circuit. So this flow of electrical energy through the circuit only makes the bulb to glow or makes any electrical appliance to work. Now we come to the main part of our topic, that is how to measure the electric current flowing through a circuit. Let us discuss about the components that are required for measuring the electric current flowing through a circuit. The first main component which creates a potential difference is the battery. Next is the ammeter, which is used for measuring the electric current. Next is the bulb, which works on the electrical energy. Switch, which makes or breaks the circuit. And finally, the connecting wires, without whom all the components cannot be connected at all. Here we have a simple circuit. Battery, bulb and ammeter. All the three are connected in series with each other. Series connection, as you all know, it is end-to-end connection. Now, this circuit which we saw previously, that is represented using a circuit diagram. Here you see a battery which is a combination of two cells is shown. The positive terminal of the battery is connected to one terminal of the bulb, and the other terminal of the bulb is connected to positive terminal of the ammeter, and the negative terminal of the ammeter is connected to the negative terminal of the battery through a switch or a plug key. Here, when the switch is on, the current starts flowing, the electrons charges starts flowing, and when they start flowing, the bulb glows, and the needle in the ammeter will deflect. It will show a reading. The reading shown by the ammeter only is the amount of current flowing through the circuit. So, what is the procedure we followed? We connected the battery, ammeter, bulb and switch using connecting wires in series. Then we noted the ammeter reading. The reading noted in the ammeter is the current in the circuit. Learning about electric current and not knowing about galvanometer is incomplete study of current. Just see the picture of a galvanometer. In a galvanometer, the needle is kept in the middle. The deflection of this needle will show the flow of electric current through a circuit. It also has a positive and negative terminal for it to get connected to the electrical circuit. In an electric circuit, even if the switch or loop is closed, it is very difficult for us to know whether the current is flowing or not. Hence, for this purpose only, galvanometer was introduced in the circuit. So, for which purpose galvanometer is introduced in the circuit? To know whether there is a flow of current in a circuit or not. It is an instrument used for detecting the strength and direction of small current presence in a circuit. So, let us recall all the points what we discussed today and let us be confident with the topics. Electric current. Electric current is the rate of flow of charges. Its SI unit is ampere. The intensity of electric current is denoted by I, which is given by the formula I is equal to Q by T. And electric current is measured in using an ammeter, which is always connected in series with the circuit. Next is potential difference. Potential difference is the work done in moving a unit positive charge from one point to the other point in a conductor. Potential difference is measured using a unit volt. It is denoted by the letter V and given by the formula V is equal to W by Q. Potential difference is measured using voltmeter and a voltmeter is always connected in parallel to the circuit. What is an electric circuit? A closed conducting loop or path which has a network of electrical components through which electric current flows is called as an electric circuit. And the schematic representation of an electric circuit using symbols of various components is called circuit diagram. And how to measure electric current? It is the ammeter using which we can measure the electric current. A simple circuit, in a very simple circuit in which we have four components, that is ammeter, bulb, battery and switch, which are connected in series. How to measure the electric current? When the switch is kept on, there will be a reading shown in the ammeter and that reading which is shown in the ammeter will be the amount of current flowing through the circuit. And finally, galvanometer. It is an instrument which is used to show the presence of current in a circuit. Thank you, children.